Hello, welcome to our live GCSE Maths session. How are you doing? I hope you're all well. Today we are going to look at equation of a straight line. We are going to see how to what form equation of a straight line is, and how to write equations, how to find gradients and write equations using gradients and points on the line. So the way this works is I will give an explanation of the topic at the beginning, and we are gonna look at some questions together. The questions I'm gonna solve are linked in the description of the video, so you can click the link and open the questions on your computer, so you have a copy. It's easier to see the questions for yourself. But let's begin now with the equation of a straight line. So we might have seen this before. We are gonna look at the y equals mx plus c form. So we'll see what each of these terms are and what they each stand for. So I will we'll see that the m represents the gradient and the c is the y-intercept, and how we can find them. So let's start with an example, so we get an idea of what equation of a line does, or equation of a curve in general does. Suppose we have got, instead of y equals mx plus c, let's put some actual numbers in. Suppose we have got y equals 2x plus 3. So what does this actually mean? If we want to plot this or sketch this, the idea is when you have an equation and we want to put it on the x, y axis, if you have this small table, the idea of the equation is that if you it gives you values of y. So it gives you values of y as you input x values, or you could do it the other way. But since we have y equals, y is on its own, so let's put some x values in. So the idea here is if you put 0 into x, you will get 2 times 0 plus 3, you will get a 3. And then you can put different values. You can put 1 in, you will get 2 times 1 is a 2 plus 3, you will get a 5. You can put 2 in, you will get a 7, and so on. So this is the idea of the equation of a line. It's going to tell us what y values we are going to get for each of the x values. You can put -1 in, you're going to get 1 there. So this, you can, if you want to say sketch this line, you can go on and actually plot these points. So what will this look like? If you have got 2x plus 3, let me put it on here. It's gonna look something like this. So this is the origin. We said that when x is 0, we have got 3. When x is 1, when x is 2, this is 5, and then this is 7. And then when x is -1, we have got 1, and so on. So this is the, we are saying that this is y is 2x plus 3. So one way of drawing the line is actually finding various values. and plotting it. But say you don't want to do that, you can have, I actually didn't put all the points there, but I just drew the straight line. So how can you do this? What does this equation actually tell you about the grade, about the line? So can anyone tell me what we get, what you know when you look at that equation and you know that it's 2x plus 3? I mentioned gradient and the y-intercept. So what does this 2 stand for, and what does the 3 represent? So the 3 there is going to be the y-intercept. You can see that the 3 is the y value there, which is the y value there. It's the value of y when x is 0. That's called the y-intercept. So that's where the line cuts the y-axis. So when you have the standard form of y equals mx plus c, the c is always going to be the y-intercepts. So this is y equals mx plus c. So that's the 3 that we have in the equation. What about the 2, which I said is the m, which is the gradient? What does gradient mean? How can we find the gradient? And what does it show us? Let's think about that. So the gradient is you can, if you make a triangle here, let me not use that. So the gradient of a line is, if you make a, say, oops. So if you make this triangle there, if you take this side of the triangle, and if you divide it by the yep, thank you, Isabella. It's the rise. If you it's that's this vertical side of the triangle that I drew there. If you take that value and divide by the run, you will get the gradient. So let's write that down. So the gradient m, which is rise over run. So how can we find that? You can see, if you wanted to calculate the gradient of this line, I am saying that it's 2, but how can you prove that, or how can you check that I'm right? I just said, oh, it's 2. The number in front of x is the gradient, but can you actually check that it is correct? What can we do to check that's the case? So this is y. How can we find the gradient there? Can you tell me what the rise here is and the run is? What are the lengths of these two sides of the triangle? We know that this point, so let me redraw that triangle here. So we know the point. We know that this point is 2 and 7, and this point is 1, 5. So how can we find the distances? What's the length of the opposite sides? What's the length here? So if you look at the x coordinates, this is going to be 2 minus 1, that length, because I took the is the same as this length, so I took 1 away from 2. That's going to be a length of 1. And then if you want to find this, you can see 7 and 7 and 5. So this is going to be 7 minus 5. So if you wanted to calculate the gradient, you can find it by saying 7 minus 5 over 2 minus 1. That's 2 over 1, which is 2. Hi Faizan, good to see you. We are just finding the gradient of this line. We have seen that it is 2 here, which is in agreement with what we were saying before. The gradient is 2, and that's the gradient m in that line, in that equation. So 2 key points to remember here: the gradient is m, whatever is in front of the x, and c is the y-intercept, which is the constant at the end in the y form y equals mx plus c. So that's the form of equation of a line. Let's see how we can apply this to some questions, which are going to be here. Right, so if you check the description, these questions are there, so you make sure you open them, and you can try them on your own as I show them here. You can have a copy in front of you. Right, the first question: line L passes through the points 8, 0, 0, 4. We want to sketch line L. So let's sketch we are given 2 points. Let's put these onto our coordinate axis. We have got 8, 0. Let's say this is 8, so that's going to be my point. And then 0 minus 4. It's a sketch, so it's not plotting. So I'm making it roughly accurate, but this is going to be minus 4, and I will draw a line through these 2 points. So that's going to be my sketch, and then we want to calculate the gradient of the line L. So calculate this gradient. Remember, we want the rise, you make a triangle, it's the opposite side, the rise over run, and this is going to be a distance of 4, and this is going to be a distance of 8. So what is the gradient that you would get then? Gradient is 4 over 8, which is 1 over 2. That's my gradient for L. Then we have got part C. Hi Mohammed, good to see you too. Line M, this is parallel to L, but it passes through a different point, 0, 6. You want to write down the equation of line M. So if it says write down, it means you don't really need too much calculations. It shouldn't take too long when it says write down. But let's think about what we need. So remember our format, the form is y equals mx plus c. Do we know the gradient of this line? And do we know c? So those are the 2 factors that you need. You always need the gradient and the y-intercept. So what's the gradient of this line? If it's parallel, so remember that if 2 lines are parallel, they have the same gradient. Having the same gradients, we know that m is going to be a half x. So that's you always need the x, plus we want the y-intercept. But if you look at this, that is your y-intercept. because y-intercept is when x is 0. So we say half x plus 6. Yep. So that's part C. We have the gradient. We agree with Mohammed. That's good. Thank you. We have half x plus 6. Then part D is asking you a question. It's about a different line n. Is line n parallel to A, L, perpendicular to L, or neither? Okay, let's firstly check the first option 1. Are they parallel? We said already that if they're parallel, they need to have the same gradient. What's the gradient of line n? 2 is, we have a gradient of 2. Well, they are, which is not the same as the gradient of L or M. They had gradients of a half. So they are not going to be parallel. But what about perpendicular? Does anyone know what how two lines would be perpendicular? What do we need for them to be perpendicular to each other? So 2 is the gradient. Then they're not parallel because gradients are different. So what do we need for them to be perpendicular? For two lines to be perpendicular, this is the other another important point to remember. The gradients need to multiply to give you -1. So perpendicular, make a note of this. Multiply to give -1. Yep, so negative reciprocal, yep, -2. Thank you, Isabella. Thank you, Mohammed. Let's explain why negative reciprocal is actually the same as what I just wrote. If you want two numbers to multiply and give -1, it's the same as saying negative reciprocal. Oops. So negative reciprocal is you put a minus sign and you flip the fraction. For example, if you had if you had a half, let's say m is a half, let's call it m1 is a half, you want m2 to be minus 2 over 1. And 2 over 1 is the same as 2. So as Muhammad said, we need them to be, we need the other line to have a gradient of -2. So check m1 times m2 is a half multiplied by -2 over 1. And that's going to give you -1. So that's if they were perpendicular, but you can see that the gradient here is 2. It's not -2, which means they're not perpendicular either. So the answer is neither parallel nor perpendicular to L, because it's the gradients are different, and the gradients, when multiplied, the gradients don't give you -1. Right. Let's look at question number 2. Let me know if you have any questions, anything you want to ask about the first one. In question number 2, we have a straight line that has gradient 6 and it passes through the point 0, -5. Write down the equation of the line. Again, it says write down, so you don't really need to do a lot. You just need to remember y equals mx plus c. Then gradient is 6. This is going to be your y-intercept. Because when x is 0, you get the y-intercept. So put it into the correct form, y equals 6x minus 5. So that's going to be your answer. It's just a write down question, so it should be quick. Then we have got question number 3. Yep, we agree with you. Thank you, Mohammed. 6x minus 5 with the previous question. Question 3, we have got 3 sketches. We want to write down the correct equation under each sketch. We are given some options, so we don't need to choose. We don't need to do them from scratch. Let's see what we have. What do you let me know? Which 3 equations you are picking? So how can we don't really have any numbers on the axis, so we don't really know the exact intercepts, but we know what the gradients look like. Yeah, Mohammed's question. Okay, if you get question number 3, let me know what your answers are. To answer Mohammed's question, what happens if the x isn't equal to 0? So if x isn't equal to 0, we can't find c directly. But what you can do is substitute that point into the equation, into x and y, and that will give. So when you solve that equation, you will find you will be able to find c. So it takes a bit longer, but we can still find c. Let me see if I think we have an example like that. So we should see how that works. Right. Let's look at question 3. So we can get information about the gradients, whether they're positive, negative, and also the y-intercepts. So I'm looking to eliminate some of these. Does this one work? Firstly, we can you can tell me whether that's an option, because you can see that it has an x squared. This is not a straight line. So we can eliminate that one. That's not going to be one of the lines. Then you can see I would look at the gradients and the intercept. So you can see there are 2 of them with the same negative gradient, -3, -3, and this one has gradient of half. This one has a gradient of 1. So 2 positives, 2 negatives, and then in terms of intercepts, we have got +5, +5, +5, and then 2 -5s. So the first one, let's look at the first graph. Alia has some suggestions. Y is x minus 5, then 3x plus 5 minus 3x plus 5. I think I agree with you. Thank you very much. Well done. Let's explain why they are actually the case. So here we want a negative y-intercept, and is this gradient positive or negative? That's how we can identify the line is going sloping upwards, so it is a positive gradient. Isabella, let's see if you agree with Alia and what I have as well. Yep, well done. That's same as my answers. So negative, let me write these down. Negative C, positive M. Here we want positive C, negative m because it's sloping down. And then finally, we have got both of them positive. Positive c, positive m. So let's pick the correct ones. As you said, both of you, thank you, y equals x minus 5. Because that works with the negative intercept and positive gradient. For the second one, the positive intercept with negative gradient is minus 3x plus 5. And then the last one, we want both of them positive, so that's half x plus 5. So I am looking at the gradients and the y-intercepts. They are, we didn't have actual values, actual numbers, but I'm just checking whether they were positive or negative. And at the beginning, we eliminated x squared plus 5 because it's not a straight line, but it's a parabola. Part B. The line L is perpendicular to the line y equals 2x plus 6. It also goes through 0, 3. We want to find equation of L. Right, two pieces of information, intercept and the gradient. What's the gradient of this? We need to find out. We don't really know that now, but it's perpendicular. However, we have got the intercept. From that, you can write C as 3. So that's the easy bit. Let's find when it's what the gradient is if it's perpendicular. So remember what was the rule for perpendicular lines? You take the negative reciprocal. And the negative reciprocal of 2 is minus 1 over 2. So that's because they are perpendicular. That means y equals mx plus c. So this minus 2 is m. Y is minus a half plus 3. So that should be your equation for the perpendicular line. It's perpendicular. We took the negative reciprocal, and that we know is going to be the new gradient. Right. Let me know if you have any questions about this one, whether you agree or not. And I am gonna move to question 4. So we have a new line L. We need to write down the gradients. So the gradient is the value before x, it's our m, so that's gonna be 4. What are the coordinates where L crosses the y-axis? So that's our intercept. So 0, minus 5. So you can see that now in the previous question we were given where it crosses. We were asked to write the equation. Now it's the opposite. We are given the equation, but we identify where those are. Thank you, Alaya. We have 4, and the crossing is 0, minus 5. So let me know what equations you wrote, or what your equation is for part C. An equation parallel to L that passes through 0, 0. So remember, you need y equals mx plus c. Let me know your equation, or let me know what your m and c values are. Maybe you're not sure of either one, but tell me what you know. So I will highlight the word parallel. Because it's parallel, m is gonna be the same as L. So m equals 4, the same as line L. And then from this 0, 0, we know that c is gonna be equal to 0. Because remember, c is always the value of y when x is equal to 0. Thank you, Isabella. Well done. Y is 4x plus 0. So we write 4x plus 0. And as your final answer, you don't really need the 0. You can just leave it as y equals 4x. That's the equation, which is a parallel, which is parallel to line L going through 0, 0. Explain how this is not perpendicular to line L. So the rule is negative reciprocal. If you're finding what it is, or if you're checking whether it works or not, you can multiply them together. So, and see whether you get -1 or not. So you can write either of them, but I will say for which is the gradient of the first one, multiplied by -1/5 is -4/5, and that is not equal to -1. So that's what you would need to write to explain that they're not perpendicular. So you could write what I just wrote, or if you want, an alternative way is saying the gradient of this line is not the negative reciprocal, and alternatively, the Alaya, that's also correct. You could say that the perpendicular line should have a gradient of negative a quarter, not a fifth. So they're all acceptable ways. Right, let's move on to the next one and see what this is about. We have a question about the gradient. Let me know if you can do this. Try it. If you already know how to do that, then we can look at how to get that. Achinta, you're welcome. It's great to hear that the notes are useful. You're welcome. I'm happy that they're helpful to you. This is question 5 about the gradient. We have got, let's read and get the information what we are told in the question. It's about how much a gardener charges for job taking different lengths. So what we can see here in this question is that it's applied in a context. Like previously we were just given x's and y's, but now we need to think about what each variable actually represents. So J is the charge. We have what J, and then T is the number of hours. So let me use different colors. J is the charge, and T is the number of hours. We are given 2 points. 2 points are 370, 845. But what does that mean? What are the points? What do the points stand for? So this means, if you were to think what the charge is and the job is, he's charging £70 for 3 hours. And what about the other one? This is saying that he is charging £145 for 8 hours. This is because we are told that T is the number of hours, and this is the T-axis. It's the first number there. The first number shows you the number of hours. That's how you know this. We are translating what's given in the question to sentences or words, so it makes sense. So it's not just x's and y's. Isabella, gradient is 15. Let's see if we agree. Yes, I do. Well done. Let's see how we can calculate that. Find the gradient. So remember, gradient is m. I'm going to use m. There can be different ways you have learned this. You can use rise over run, or change in y over change in x, or y1 minus y2 over x1 minus x2. But remember, here we don't have x and y, we have got j and t. So to calculate that, we do what Isabella said, 145, which is the one of the j values, minus 70 divided by 8 minus 3. So what we are doing is making this triangle, finding that distance, finding this distance. So that there. And what did we say the answer was? 15. Yep. Okay, 15, everyone. You should have the answer as 15. Let me know if you have anything different. Where was there was a question, our boss, but I can't, yeah, I think, yeah, there was a question, I'm not sure what that was. You have got exams for June. I hope you do well. It's I mean, yes, some like maths can be hard for some people. Not everyone finds it easy. I know I've taught many students, but I think the key advice I can give you is don't be afraid. Like, there's nothing intrinsically scary or difficult about maths, as long as you try to understand the topics, what they mean, and how to do them. You practice them enough. You can actually do them. You can do most of them. So don't be afraid of maths. Yes, some people find it easier, some people find it more difficult. That's absolutely normal. But don't be afraid. Make sure you practice and try and understand what's how things work, and try to relate it to things that you actually know about, so that it makes sense for you. And yeah, you're welcome. I'm happy to hear that it's the videos or the resources are being helpful to you. Right, let's continue. Part B, work out the equation of the line to give a formula for J in terms of T. Right, so I hope things are becoming a bit coming together here. In the sense that we have got a context. So previously it said find the equation, and then we wrote something in y and x. But now we want to find a formula for j in terms of t. It's still the same thing really. We need to find an equation, but instead of y, let me make it a bit bigger now. So instead of saying y equals mx plus c, what was our y before? On the y-axis we had j, so j is gonna be our y, and then mt plus c. Other than that, it's still the same approach. You use your m, which is the gradient that you found. So j is 15t plus c. Do we know what c is? What's the where does the line cross the y-axis or the j-axis? Do we know c? So I think this is I think it was Mohammed. You asked what happens if we don't know c directly. We're not given. You can see that none of these points have a 0 at the beginning, so you don't really know what c is directly. So what can we do in that case? So what we do is we take one of these points, let's say 370, and then substitute into this equation. So at 370, 70. So from there, I'm going to continue. And I'm going to say, we know that 370 must satisfy this equation. So if I put 70 pounds into J and then 3 hours into T, this equation must work. So that's what I'm going to do. 70 must equal 15 times 3 plus C. Otherwise, the equation doesn't make sense, because remember at the very beginning, I was saying that the whole point of an equation is you put x values, or you put t values in this case, to get j values out. So we know that this must work. So 70 is equal to 45 plus C. Make C the subject. 70 minus 45, which is equal to 25. So this is how we find the value of C if you don't have a point or a coordinate with 0 at the beginning, or x value of 0. Oops, sorry about that. Therefore, J equals 15t plus 25. So we have an equation for J in terms of t now. Can anyone tell me what these actually mean in terms of what he charges and how how long he works? We have got two values here. We have got 15 and we have got 25. What do they actually stand for? What is let's simplify my question. Let's start with, what is his hourly rate? Can someone tell me what his hourly rate is based on this equation? Because we have established that J, which is what he charges, is 15 times T, which is how long it takes, plus 25. So let me know in the comments what you think his hourly rate is. Thank you, Kashai. Let me know if you know the answer, what the hourly rate is, and also what the other number is, because one of these is the hourly rate. Of course, don't just pick one, explain. That's fine. Yep. So our hourly rate is 15, going to be 15 in this case, because the equation in the equation t is how long he works. So what we are saying is, if he works 2 hours, it's going to be 15 times 2. If he works 10 hours, it's going to be 15 times 10. So this is going to be the hourly rate. Thank you, Farah. And then what's the 25? 25 is the fixed cost, or the initial charge. So if he, let me see what this was. He's a gardener. So this is, if he goes for a job that takes 2 hours, he will charge 25 plus 2 hours times the hourly rate. So this is the fixed or initial charge. He wants to charge that always, because it makes sense. If he goes for just 1 hour, he doesn't want to charge just 15 pounds. There's a fixed rate to cover the cost of, say, traveling there or anything, any other fixed cost. So that's always going to be the case, and then you add the hourly rate on top of that. Right, let's move on to this one. This is going to be the last question I'm going to do. So we have got a graph, Satsumas from the market, how many Satsumas she's getting, and how much they cost. So these are the two values we have. they are plotted on a grid. We need to draw a line of best fit. There's going to be my line of best fit. Yeah, that's roughly correct. So I've kept two of them a bit above the line. These are below. I've tried to pass it through a couple as well. So you should draw something like that. Let me extend it so that we can see our intercept as well. Then we want to calculate the gradient, giving the answer to the nearest whole number. So for the gradient, you can make a make a triangle to find the rise and the run. So I'm gonna make it as big as possible. That's gonna be my vertical one. Then that's the line there. So this is I've gone to the edge, so that's 11 there, and you can see so we can say that this is 119. This may be a bit different depending on what you draw, but that's a difference of 119 minus this is 12, so that's 107, and this side it goes from 0 to 11, so that's just 11. So the gradient, you need to do 107 divided by 11, and I get 9.7, which is to the nearest whole number is gonna be 10. And this is it's okay if you get different answers depending on the line of best fit that you draw. Then part C is asking about the context. What information about this about Satsumas does the gradient represent? Let me know what you think about that, and then try part D. Let me know what equation that you get. So the gradient, we have got how many Satsumas she gets and how much they cost her. They are the two values on the axis. So the gradient, you can, if you think about the previous question, we had the gradient, that was the hourly rate. So for each extra hour, how much more he was charging. Here, instead of hours, we have got Satsumas. It's a cost again, it's similar, but the idea is the gradients are always gonna represent when you add an extra quantity of whatever is on the x-axis, how much the y increases. So in general, the gradient shows how much y changes when x changes by 1. So this is the general meaning of gradient, but in this case, what if you think about what your x is and what your y is, you have got cost of Satsumas. So in this case, the gradient represents the price per subsum. And then finally, you need the equation in terms of y and x. We have got the form y equals mx plus c. We need the gradient. So we are going to write the gradient. I have got 10x plus c. How are we going to get c? If you look at what I drew there, my intercept is 12. So again, it depends on, this can change. It doesn't have to be 12, but it needs to be whatever value you have got on the y-axis. So 10x plus 12 is my equation for the last one. And this is where I want to stop today. And there are, let me see, I think there are a few more questions in the worksheet if you wanna try them, and if you have any questions about them, let me know in the comments. I will also upload the my solutions to the I'll update the file with my solutions as well. Thank you very much for joining. I hope this was useful for you. If you enjoyed the video, please hit the like button and subscribe, and let your friends know. We have these sessions weekly on Wednesdays for GCSE Maths, and there will be one next week. Next week's let me see what next week's topic is. Yep, next week we are going to look at indices. So I thanks for coming. I am gonna next week is indices, Mohammed. So I hope to see you next week on Wednesday for indices. Bye, and have a nice evening.